Today we're going to take a look at 8.6. We're going to rewrite radical expressions and radical exponents. And then we're also going to simplify radical expressions. Now, prior to this, you have used the properties of exponents and you've simplified them. And there's several different rules that we played with. Today we're going to use those same rules. But before we worked with integers, today we're going to deal with more than just integers. We're going to deal with rational numbers. In other words, a fraction in the exponent. And we're also going to convert between a radical, for example, the radical that you see there, and we're going to convert that into a rational exponent. So that's where we're headed for today. Okay, I want you to start out with today, and let's review those properties of exponents. So I want you to do these 5. So go ahead and pause it and do these 5 questions. Okay, now let's take a look at what you've done. On the first one, notice you're multiplying like bases. So yes, you're going to add the exponents. So you are going to get a 7 to the 5th, and if you enter that into your calculator, that's what you come up with. In the second one here, you're dividing, so therefore you're going to subtract the exponents. So you're going to get 11 squared, or 121. For the third one, you have a power to a power. So remember, when you have a power to a power, you multiply. Alright, so it's going to be 3 to the 6, or 729. Now, for these two here, you needed to remember how to go about this. When you go about this, remember you're asking yourself, is there a perfect square in 75? So, what is a perfect square that goes into 75? Well, 25. 25 goes into there 3 times. And the square root of 25 is, yep, you said it, 5. So 5 radical 3. 5 radical 3 is our answer. Okay, so in this one here, you had to rationalize it. So let's take a second and let's just kind of review that a little bit. You have the square root of 20. So let me change the pen color to something you can see. Okay, so you have the square root of 20 over the square root of 7. Now, in order to get rid of the radical on the bottom, you need 2 7s on the bottom. So we're going to multiply by the square root of 7 over the square root of 7. And notice when you multiply by the square root of 7 over 7, that's just a fancy way of writing 1. Now what's going to happen here is on the top you're going to have the square root of 20 times 7. Now, as I'm going to think ahead here a little bit, because 20, remember, is there a perfect square in 20? Well, yes, 4. So I can see that's going to be 4 times 5 times 7. And on the bottom, you're just left with 7. Now, the square root of 4 is 2. So I can see it's going to be 2. And 7 and 5, I can't do anything with that, so I'm going to just leave that as radical 35 over a 7. Now don't be confused. Remember, yes, 7 does go into 35, but 7 does not go into the radical 35. So we are done at that point. So our answer is 2 radical 35 over 7. Alright, now let's look down below here a little bit. When we look down below here, we see we have a couple vocabulary words that we're going to be learning this time around. First one is index, which we have talked about before, and then rational exponent, which is something that's brand new for us today. Alright folks, on this slide we're going to explore a little bit. So take your graphing calculator or your device or your regular scientific calculator, and I want you to look for the cube root key. Your cube root key is going to look like something like that. Okay? And some of you will put parentheses around there. Some of you will already have parentheses there. And I want you to type in a 27. Okay? And then hit your return key. And it should give you 3. Okay, next we're going to do something else. I want you to take 27, type that into your calculator, then do a caret button like this, then put a parenthesis, and then type in a 1/3. Now what you're entering is you're entering in 27 to the 1/3 power. Now hit return, and what does it give you? You're right, it gives you 3. That tells us that the cube root of 27 is equal to 27 to the 1/3. Alright, so now that we've explored that a little bit, and since I know this exists, that would also tell me that if I converted this x to the 1/3, and if I played with that, I could actually change that from exponential to radical form. Now maybe you're saying, where does this 1 come from? Well, how many 27s do I have here? And when I'm saying a 1 here, let me point to what I'm talking about here. Okay, you're saying, well, where does this 1 right here come from? See the 1 over 3? Well, how many 27s do I have right there? Well, we have 1. Okay, so this is actually, if I look here, 27 to the 1/3. So if I follow that same pattern, I'm going to get up here, I will have a x, and remember the third is out here, the 1 is there. Alright, so that just explores a little bit that. Now, I have some problems that I just want you to play with. So with your calculator, there are 6 problems here, and I want you to just calculate or simplify each one of these calculations. Alright, go ahead and pause it and do that. Okay, when you're doing each of these, for the first one, you should have ended up with a 2. For the second one, what'd you end up with? Yeah, a 2. Same thing. Cube root of 8 is the same as 8 to the 1/3. Okay, then I have 16. What'd you get? Well, yeah, that's going to be 4. But what was 16 to the 1/2 power? That's right, it's 4. Okay, and cube root of 125 was, yep, it was a 5. And then 5 to the 1/3, what was it? It was 5 again. Alright, so that's interesting. Alright, well, let's learn a property. Let's put a property down in our notes that goes along with this. Before we get into converting radicals to rational exponents, let's define what a rational exponent is. A rational exponent is an exponent that can be expressed as m over n. Now remember, m and n are going to be integers, but tell me about n. It cannot be 0. Okay, so now remember, radical expressions can be written by using what? Yes, rational exponents. So today we're going to rewrite radical expressions using rational exponents. And below here is the property. So go ahead and pause it if you need to get that definition down. And then we're going to take a look at this property. Okay, this is, for this property, again, we've already done a few of these. If I have 6 to the 1/4, that's equal to the 4th root of 16, which is, of course, 2. So here's our property right here. Here's our property. If I have a to the 1 over n, that equals the nth root of a. Okay, and where's that 1? Well, that 1 is like right there. Okay, so if I were to take a look at, say, 8 to the 2/3, I see by looking at this, it's going to be 8. Notice the 2 is on top, so it's going to be there, and the 3 is on the bottom, so it's going to be there. Now, I do want you to know that I could have written it a couple different ways. Okay, and I'm going to show you that here in the algebra piece. So let's go ahead and look at this. I have a to the m over n, which is equal to a. Now n is your denominator. Okay, so it becomes your index right there. Your m, it can be one of two places. You can have it, you can put parentheses around this and put your m out there, or you can write the m as the exponent for the a. So it can be one of these two. And you're going to want to write it as one of these two based on the problem. Okay, so let's go ahead and let me make this a little bit bigger and just kind of show you what we're looking at here. So here's our property. If I have b, the nth root of b to the m power, remember this here is my numerator, this here is my denominator, so it's going to be b to the m over n. Let's take a moment and let's review our properties of exponents. Remember our properties of exponents here. Remember, first of all, we had if we multiply, then that means we add. If we divide like bases, we subtract. If we have a power to a power, you're going to multiply your powers together. If you have ab raised to the m, you take both a and b to the m power. And same with division here. Okay? Now, the same things apply for rational exponents. So these are the properties of rational exponents. So look here in some of these examples. If you have 12 to the 1/2 times 12 to the 3/2, What are you going to do to the powers? Well, before we added them, we do the same thing now. We're going to add them together. So we take 1/2 plus 3/2, which gives us 4/2, which is 12 squared, or 144. Okay, it's the same with subtraction. If I have 125 to the 2/3 and 125 to the 1/3, well, we have like bases, so we're going to subtract the powers. So there it is. So it's just 125 to the 1/3, which we've already looked at, which is 5. All right, and if you have power to a power, notice you have 8 to the 2/3 raised to the third. That's the same as 8 to the 2/3 times 3, which will give you 8 to the 6/3, or 8 squared, which is 64. All right, so let's go ahead and take a look here at these just a little teeny bit bigger. Okay, so if I look at these properties here, so what's going to happen again? Let's just review. If I multiply like bases, we add the exponents, so m plus n. If I divide like bases, we are, you said it, subtracting our exponents. If you have a power to a power, what you going to do? I agree, you're going to multiply. Okay, and of course in this situation you're going to raise both of them to the power here. And remember, there's a little imaginary 1 that you have here and here as well. So then it's kind of the same as this property up here. Alright, so what you're going to do is it's going to be a to the n, b to the n. And likewise down here, remember I have a little a to the first there and I have a b to the first there. So it's going to be a to the, and it's a power to a power, 1 times m, which is so a to the m over b to the m. Alright, so with that in mind, let's go practice some examples. Okay, let's look at this slide and practice a few problems here. So go ahead and pause it and work through these 5, and then we'll talk about it together. Alright, let's look at the first one here. And the first one here, you had like bases, and you're multiplying, so you're going to add. So when you add those together, you should have gotten x to the 1/2 plus 3/2, which gives you x to the 4/2, which gave you x to the second. Alright, that's the first one. For the second one, notice you're dividing like bases, so you're going to need to subtract. So y to the 2/3 minus 1/3, which gives you y to the 1/3, and you're good. Okay, this one here on C, you have a power to a power, so it's going to be z to the 4 times 1/2, which gives you z to the 4/2, which gives you z to the second power. Okay, good there. Now, this one here, remember, you're going to take everything to the half power. And remember, there's like a little 1 there and a little 1 there. So it's going to be a to the 1 times 1/2, or just a to the half, times b to the 1 times 1/2, or just to the half. And you can just leave it like that. Alright, on this one here, you're going to do, this time you're dividing, but you have both of them raised to the 4/5. Remember, there's a little 1 there and a little 1 there, so it's going to be c to the 4/5 divided by d to the 4/5. Alright, now, here, remember, this number right there is like a, well, it is an index, which means I could rewrite that as the 5th power of d to the 4th. Now, up on top, I'm going to put the same, I'm going to convert it as well, so c to the 4th. Now, if you look at this denominator right here, I can't have that. I can't have a radical in the denominator. Now, how many d's do I have here? Yes, you see it's 4. What's that index say? 5. I need how many of these to get rid of the radical in the denominator? If you said 1 more, you are correct. So, I am going to multiply the top and the bottom by the 5th root of d. Alright, and the reason I do that is so that I end up with, I have d to the 4th right here, I have d to the 1st right here, so that's going to give me the 5th root here of d to the 5th, which will simply be d. Okay, now on top, I'm going to get the 5th root of c to the 4th and a d. Alright, now let's go ahead and simplify that a little bit. Since this piece right here is going to become just d, and then I have gotten rid of my radical in the denominator, On the top, I still will have the fifth root of c to the fourth, d, and the bottom I would just have d, and now it is simplified. Okay, folks, this is all for today. The problem set, you can see it right here. We're going to play with those this next class period. And tell you what, how about a little Easter egg? So, here's what I want you to do. Send me a quick email at cliffordfrench@usd475.org and tell me your thoughts about this fantastico video. All right, we'll see you in class. Have fun. Oh, and one more thing. Shh, don't tell your classmates about the Easter egg.